Hello, this will be a demonstration of proposition 3 from book 4 of Euclid's Elements, which requires us to, about a given circle, circumscribe a triangle equiangular with a given triangle. The last proposition we had the inscription of a triangle, and this time we have the opposite sort of construction, the circumscription of a triangle. What we are given is a circle ABC, and we are given some triangle DEF, which I'm going to make equiangular just for the sake of ease, although the triangle doesn't have to be equiangular, of course. And given these, it is required for us to, about the given circle ABC, circumscribe a triangle equiangular to DEF. We begin by producing EF in both directions to the points G and the point H. We do this by postulate 2. And next we find the center of the circle ABC, which we're going to call K. We do this by proposition 3(1). Next, we make the angle BKA at the point K equal to the angle DEG. So we take this angle DEG, and about the point K, we will make an angle equal to it. So that would look something approximating that. BKA. So we have the angle BKA, like so. And this angle here will be equal to the angle DEG. We do this by proposition 123. Now again, we make the angle BKC equal to the angle DFH. So that would look something like that. We have the point C right there. And this angle BKC will be equal to the other exterior angle DFH. Again, we did this by proposition 123. And next, we make the straight lines LAM, MBN, and NCL tangent to the circle ABC at the points A, B, and C, respectively. We do this again by the tacit construction in the porism of proposition 316. Let's do that. So let's make this straight line like so. And we'll make this other tangent straight line like so. And we'll make the final tangent straight line like that. We'll call this point L, we'll call this point M, and we'll call this point N. Now, we know that because LM, MN, and NL are tangent to the circle, we drew them in that manner. We know that the angles here at the points A, B, and C must be right angles. We know this by proposition 318. So all those angles about the points A, B, and C are right angles. Now, there's an interesting step that goes on here. Let's look at this quadrilateral where is it? Where is that? I appear to have messed something up. Oh, gotcha. There it is. Okay. Just put the points in the wrong places. Should be like that. Now, if we look at the, I've got to rotate things again. This is all my bad. I'm very sorry for this. Okay. Ooh, that's ugly. That is less ugly. Okay. So if we look at this quadrilateral here, KAMB, we look at this quadrilateral, we can divide it up into two triangles. We can divide it up into the triangles KAB and AMB, right? We can say that. Now, we know that the interior angles of both of those triangles, KAB and MAB, must add up to two right angles. That's proposition 132. And we see that the whole quadrilateral KAMB, it involves all the angles of these two triangles, KAB and MAB. So it has the sum of all of these, of all the interior angles of these two triangles, KAB and MAB, which means that the sum of the interior angles of this quadrilateral, being composed of two figures whose interior angle sum is two right angles, if we add two of those together, the sum of the interior angles will be four right angles. This is a use of common notion 2, actually. So the interior angles of KAMB add up to four right angles. Now we showed in the previous step that all the angles at the points A and B are right angles, and that would mean that the angle KAM and the angle KBM are right angles. And so if these two add up to two right angles, then the remaining angles BKA and BMA must also add up to two right angles, so that the four of them together can add up to four right angles. This is sort of a use of common notion 3. Now, we know that the angle DEG and the angle DEF, those two angles by proposition 113 must add up to two right angles. And so we have two things which both add up to two right angles. So by common notion 1, we can say that the angle AKB plus the angle AMB equals the angle DEG plus the angle DEF, of which we know that the angle AKB and the angle DEG are equal because we made them that way in the first step. And so we can subtract those equals from both sides and say that the remainders are equal. That's common notion 3. So we can say that this angle LMN right here, LMN is equal to the remaining angle DEF. Now we can show in a similar manner that the angle LNM equals the angle DEF. LNM, okay. We can show this in a similar sort of manner, observing the quadrilateral BKCN. We know that the interior angles of it add up to four right angles. Two of its angles are two right angles, and so the remaining angles must add up to two right angles. Then we also know that the angle DFE plus the angle DFH add up to two right angles, and so the angles BKC plus the angle BNC must equal, by common notion 1, angle DFE plus angle DFH, of which we know that the angle BKC is equal to the angle DFH, and so the remaining angles must be equal. That is to say that the angles LNM is equal to the angle DFE. And when we know that two triangles have two angles equal to two angles, we know that the remaining angle, the third angle, must be equal, right? Because in these two triangles, DEF and LMN, we know that their interior angles must add up to two right angles, and so their interior angle sums are equal because they're both triangles. And we know two of their angles are equal, so we can subtract them from both sides and say that the remaining angle is equal. In this case, that would be to say that the angle MLN is equal to the angle EDF. I don't know where that angle, ML, gotcha, okay. That, lots of equal angles. And so what we have here is we have the triangle LMN, which we see is circumscribed about the circle ABC, and it is equiangular to our given triangle DEF, which means we have done that which we set out to do, to, about a given circle, circumscribe a triangle equiangular to a given triangle, which means we're done with the construction QEF. I have nothing to add to this proposition, so I will simply move on to proposition 4.4.